All right, hi, we're going to talk about Chapter 9 today. It is manufacturing and operations. Pretty critical part of the business cycle, I would say. One of the big arguments that goes on these days is what America makes anymore and how we've turned away the labor force. And I think that argument is old and unrealistic. First of all, going back in history, societies evolve by starting to make stuff, getting good at that, maybe getting better at selling them, maybe better at distribution, and then beginning to manage that production. And possibly with globalization, that production goes overseas. My point is the advanced societies, Japan, Germany, USA, a lot of Europe, they get good at making and then they get good at service industries and servicing what they make. By service industries, that means not manufacturing, but service. But it's still business. So goods and services are still being produced. And that's what's kind of difficult for some people to understand, that services is operations, just like anything else. We do make a lot of stuff in America. We just don't make little trinkets like pens and backpacks. Obviously, lower labor countries. If it's not China, it's going to be somebody else. We've got 50 years to exploit Africa to go. We've got China's already outsourcing product to other neighboring nations. So that whole argument's old. If you want jobs in today's economy, look to the service industry, and I'll explain a little bit about what that is. So we do make a lot of things. We do a lot of industrial things. We sell tons of petroleum products to the rest of the world, and big planes and ships and jets and stuff like that, and food. We make a lot of food. We make a lot of food for our own domestic economy, like most countries do. So what we're talking about here in this chapter is operational management, and basically you got to have, it's an entire study, it's an entire career for many different sectors and areas. Who's managing what product is coming in? Where do you get it? We're going to talk about quality control, which is super important. Production and scheduling, we're going to talk a little bit about, and how this all works and comes together. Production is pretty simple. Think about the inputs of stuff. Now let's talk two lines through. One of them is a simple thing. It's a good, and if I could take this pen, I would say you're taking inputs. What's an input? Well, petroleum to make plastic. There's a metal spring in here, and there's a rubber tip. Those are raw materials. You certainly would need labor, somebody put it together. You need money to build molds, and you'd have to have the knowledge and entrepreneurship to know how to put this together. Again, I'll show you a little bit about that. So what this chapter is, what these people do in management and operations. Operations is planning and scheduling and dispatching and follow-up. Think about it has to be produced, maybe put in a store, sold. That's a big process for just this one little pen. And that's what we're getting as goods and services. If you had, let me mention services. What if you were a tax auditing company? You would have the labor, the capital, and the entrepreneurship and knowledge to do that. Maybe you need a place to do it too. And you'd have the same kind of production going if you were a tax service. You hire somebody and you're paying that person to do the tax service. So services and goods do follow the same production process. And it's hard for people sometimes to understand that goods and services do have a production. A service is a production of some sorts here. One of the things that's kind of shocking is how big our economy is and how many things are made in a minute. Imagine, I used to talk about potato chips. I used to have a statistic about how millions and millions of bags of Doritos potato chips are made in a day. Millions. It's unbelievable. So who's doing all that? There's a big machine behind the production of a simple thing like a bag of chips. You think nothing of it when you open it and you eat it in 5 minutes. But that's production. Twinkies. Who knew that they make 1,000 Twinkies in a minute? Not know that. So over history, Americans and Europeans and modern society over the last 20 years has gotten very good at manufacturing and production. We've increased our efficiency, which means you kind of lose people and labor doing it. More people are doing the work of others because we have CAD design for manufacturing, lean manufacturing, mass customization, robotics, 3D printing. We have a lot of modern technology tools for manufacturing that we didn't have just a little while ago. 20, 30 years ago, we didn't have that type of thing. So things have changed so much just in the basics of producing things. And I want to show you a little bit at the end some CAD tools, computer-aided design. Everyone should know about this. In fact, Front Range has one of the better leading schools to train people in CAD design, which is virtually these days a guaranteed job if you know how to do that kind of stuff. It's a great program and system. I'll show you in a fun adventure at the end of this video here. But everything needs to be designed before it's made. So there's a lot of service in that. There's a lot of work in design, and the back story between design and output is a long one. So what do managers do? Well, they have to look at where are we making this stuff, and does that location make sense for the people, for the transportation, for getting raw materials, for all that kind of stuff. How do we lay that? All the things that people are having to do. I mean, purchasing is an entire team of people's job for things like this, these pens and doohickeys that we're producing. Teams of people are on inventory control and quality control. It's a complex world that we live in with lots of those. Just for example, location studies. You know, how do you decide where you're going to be? What kind of places do people want to work? What kind of labor do you want to have? How close do we have transport? And what's the cost of living? And what's the quality of life like? What kind of people are you going to get? There's a lot of questions to just location study right there for manufacturers, just that alone. I want to touch on a couple of quick basic items. JIT, just-in-time inventory control, is kind of taken over. It's very important. During the virus, we saw a lot of problems and holes in the supply chain. If one link in that supply chain is broken, then it messes a lot of things up. Just-in-time, of course, means that when we're assembling this pen and putting this part onto this part and onto this part, we don't stock up a whole mountain full of these parts. We get a shipment. We're going to make 100 or a couple thousand today. We get the shipment in a few days before that, and you get it just in time, and it goes out. So that you're not holding a lot of inventory. It's very squeaky clean, cost-effective, and efficient machine with just-in-time inventory. Another really important thing is quality control. People, ask about China production, and I say it's all about quality control. How in the world does somebody like Patagonia or North Face or any of the top quality lines, how do they get good quality? Well, it's QC, it's quality control. They will test every one, they rip every one. It's time consuming, it's part of production. It's coming off the assembly line, you test it, it's good. They also spare no expenses in materials and design. So they design it so it's not going to break. So QC is the key to production. It really is. Six Sigma is a percentage defect where you're working down the number of percentage defects. It's kind of hard to explain in 1 minute, but it's a quality control measure that is very calculated, and exactly how do you reduce defects down to the smallest percent close to zero as possible. Those are important things. The other things that manufacturers need to know all about is ISO, International Standard Organization, came up with standards of how to produce certain things. So an industry of 9001 might be one industry. There's lots of ISO and numbers according to different industries. There's a glass industry standard. There's an electronics industry standard. All these different ISO standards. And basically, I've been through this process. They go to the factory and they say, how are you producing? How are you quality controlling? What happens to defects, and what do you do to repair the defects? It's just a quality, systematic approach to things that is an international standard. When somebody like Walmart wants to buy from a factory, what do they choose? They're going to choose a factory that has ISO, whatever number, ISO 9000 certification. You pay for it, you get people to come in and check your factory and know that you're doing production right. That's what ISO is all about. A couple of different charts about how to plan for manufacturing production. These are actually better or well used for services. Imagine what are we doing here? They're having an event here. So if you're going to have an event with dancers and costumes, and you need sets constructed and rehearsals and videos and all that kind of stuff, there's a planning process. A PERT chart is more or less like a flow chart that's pretty handy, but I do want to show you a Gantt chart, which is nothing complicated about a Gantt chart, but The reason why I say this is because I've seen those used. And the nice thing about those, you can produce one on an Excel spreadsheet super easy, where you just say, let's say we're going to plan a party, a big grand opening event for our business. Say, well, I got to book the venue, I got to pick the date, and that happens on this date. And then here's the end date. What do we have to have? I have to have entertainment. I got to start talking to them at this time. And then it's great for handing it around to other people. This type of event planning doesn't happen by one person by any means in the real world. So you have another number of people who are helping in the design of this event, we're saying. So each person knows what is due. And the nice thing I say about the Excel spreadsheet is I've seen those. You just email those to other people with updates and changes, and everybody knows who's on track. And then the project manager can say, okay, everybody's on track. If there's a problem, our timing isn't met here, we have to pay the vendor by this date. We have to have the chairs at the event on this and the tables, so we have to rent them before then. We have to have them there before the event at this time. Who's setting them up? And when do the chairs have to be back to get the deposit back? All the little tiny details are in these types of things. And the Gantt chart is very useful and handy. So this is interesting. I'm going to try to go through a fun adventure of production of a product that I worked on a couple of years ago. It's called a Wingo. This is the more modern version right here. This is a few years ago. They went and retooled it completely back in San Francisco. But we made molds in China. But I wanted to point out AutoCAD. Because I say you got to make shapes, and how do you come up with that shape for the mold to be produced? And this is kind of the story. Basically, a simple product, something as simple as this. It's just a phone case, right? Any old phone case. Think about a stapler. How many parts go into a stapler, and it's got to be exploded out and examined. An AutoCAD program will take each one of these parts. You can take this unit right here, and you can expand it all the way down to the most minute micro and make changes in the size when it doesn't fit together. That's basically how it works. So we're working on an AutoCAD program, which actually looks like this. Pretty complicated. It's $3,000 or $4,000 for the program. Training takes years. It's very cool, very handy. You can be employed very easily by working with these programs. You can take this thing right here. Let's say the plastic is the green. And here's a rubber foam piece right here. I happen to know this is a magnet that holds the things down. So I can take that magnet piece apart and check the sizes and everything like that. Very cool stuff. You can spin it around and blow it up and take this part out and this part on. It's just all a design. And you can make the lines tighter when it doesn't fit. That's how it is made. Here's kind of cool how it's starting to come together. You can see these little parts here all slapped together. We're going for that. Parts come together here. We're tweaking every size possible to make everything fit. Obviously, this is a handheld device that has to have a fit, and different types of material are put together. Here's some other design looks of the whole thing. And finally, one particular output with a kind of a clear, glossy plastic. These are like rubber tips, so they kind of grip on here. There's some rubber lines in here. That's why it's so complicated. On the other side, there's a foam piece, and there's magnets inside and everything like that. So I hope that was interesting, how to produce things. And there's a lot of interesting ways to look at great opportunities in manufacturing production. Thanks very much.